Hey folks, so this is your lesson video on section 11.3, this introduction to vectors. You'll notice that the entire first page is just simply a page of terminology. I go into a lot more detail on the notes portion of that, so please, if you haven't watched the notes video, even though you could just fill in the blanks right here, if you haven't watched the notes video, you need to go back to that video and watch for understanding. I'll make a couple of comments in this video, but then I'm going to go ahead and just jump right on into examples. The first comment that I'd like to make is that you'll notice that in a vector, I always have a starting point and an ending point. You'll also notice that the ending point has an arrow on it, and the arrow does not indicate that it keeps going on forever and ever because it's ending. It just simply tells you which direction it's going. So that's one thing that I'd like to mention to you. Also, if you go down, please pay special attention in the notes videos about the two ways to write a position vector and what a position vector is. So this is one way to write a position vector where you use the pointy brackets. And then the second way to write a position vector is by using the I's and the J's. Notice that I'm either using X's and Y's or I'm using A's and B's, and I am going to be going back and forth quite a bit throughout the rest of the chapter, quite frankly. So sometimes I'll talk about the A's and the B's, sometimes I'll talk about the X's and the Y's, but they're the exact same thing. We will also be discussing the magnitude and the direction angle a good bit. So again, make sure that you've gone through the notes video and that you understand what the notes video says before you just jump right on into examples. It might be a little bit confusing. All right, so for example number 1, you'll notice that I've been given two vectors. Both of these vectors are position vectors, and I know that because they're written in the I and the J form. So both vectors are position vectors. I've been told to find a new vector, and this new vector is vector v minus 3 times vector u. This is actually almost pre-algebra. You don't even have to know anything at all about vectors to be able to know what's going on here. So all I'm going to do is I'm going to write down my vector v. There it is, just copied it down. And I'm going to subtract a 3 times, and I'm going to write down my vector u. At this point, I'm going to keep my vector v there. I'm not going to touch it yet. But I am going to distribute to the two pieces of my second vector. And so you have a negative 3 times a negative I is your plus 3i, and a negative 3 times a positive 2j is your negative 6j. At this point, I can combine my like terms. If I combine my i's, combine my j's, I'm going to get the new position vector 4i minus 7j. Example number 2 is the exact same concept, it's just using the other notation. You'll notice here that these are pointy brackets. I know it's not very obvious, but they are pointy brackets, so be careful when you see those. So I've been given two position vectors. There's one of them, and there's my second one. I'm asked to find a new third vector. And so once again, I'm just going to plug and chug. So there's my 2 times my vector u plus my 3 times my vector v. Let's go ahead and distribute our scalar. By the way, scalar was one of the terms in your notes video. So distribute the scalar, and you'll get two new vectors. Once you have those two new vectors, you can combine your A pieces and you can combine your B pieces. Or you could say you can combine your X pieces and you can combine your Y pieces. You have a new video, a new vector, I'm sorry. All right, next, we've seen this particular picture several times in our notes. You'll notice that I'm taking the position vector AB. Remember, that means that I'm starting at the origin and I'm ending at the coordinate AB. So since I'm ending at the coordinate AB, I know that my X value is A. I know that my Y value is B. And then we've always called the hypotenuse either the hypotenuse or the radius. And so I'm going to continue to call it the radius. This is also the length, the magnitude of vector v. And if you'll go back to the notes video, magnitude is always denoted by these absolute value symbols. Okay, so that's going to be my magnitude or the length of my vector. The length of my vector is the same thing as my radius was in the past. All right, so if I'm looking at my picture then, in order to find my sine value, that's going to be opposite over hypotenuse. So that'll be my b value over my r value. Cosine is adjacent over hypotenuse, so that's a over my r value. Well, if I told you to get the b piece alone and get the a piece alone, you would just simply multiply on both sides by r. So this would be a is the same thing as r cosine theta, and a is the same thing, or sorry, b is the same thing as r sine theta. These are really, this is why they're in highlighted format here. These two are really important formulas that you're going to use over and over and over again. So let's go ahead then and put them into practice. Now, before I move on, let me come back to this picture for a moment, because I want you to start splitting your brain for every single question into two categories. Category number one is going to be the legs category, and category number two is going to be my r's and thetas category. Every single question can be split really most of the time even into, hey, I have legs, let's go find r's and thetas. Or maybe I have r's and thetas, let's go find legs. You'll notice here that when I came up with these two new equations, you'll notice that the a and the b, these pieces, these are the legs of the portion. Go look at the picture. You see how the a and the b are the legs? And over on the other side of the equal sign, there's nothing but r's and thetas. And so I've split up into two sides. One side I have legs, and on the other side I have r's and thetas. So constantly be reminding yourself, what do I have? What do I want? So let's look at number 3. It says to write in the form, and it told me to write it in the form of the position vector AB. Now look at your picture. What do you have? Well, you'll notice that you've got on your picture here, you have an r value and you have a theta value. So you've got r's and thetas. What are you looking for? The directions tell you that you should be looking for a's and b's, and we know that those are legs. Okay, so I'm going to use my handy dandy formulas that I just came up with. So since I have r's and thetas, I'm going to plug those in, and then I'll do the work to be able to find the legs that are missing. So first, I'll set up my first equation. A is equal to r cosine theta. Plug in your r and your theta. Use your unit circle, folks. 120 degrees is on the unit circle. Not to mention the fact that the directions say that we should be using the exact values. So the cosine of 120 is going to be -1/2. Multiply that by 7 and I get -7/2. I'll come back to that in a minute. Let's go find the other leg. The other leg was for side B. Plug in your r, plug in your theta. Use your unit circle. The sine of 120 is √3/2. Multiply that by 7 and you have 7 √3/2. So I found the legs, the A and the B, but what I haven't done is I haven't written it properly. So that's the last step that I want to do, is to write my A and my B in the position vector format. All right, look at example number 4. Now on example number 4, this one I actually would have a different set of instructions. I would not tell you to find exact values here. I would just simply ask you to find the vector, and you'll see why in just a moment. So once again, when you ask yourself the two questions, what do you have? What do you want? And so when you look at your picture, you have an r and a theta, and when you go back to the directions, you're being asked for legs. So let's set up our two equations. We'll go ahead and substitute the radius and the theta. Now, I don't know anything about 220 degrees, so here's where I'm going to use my calculator. And that's great. I have found my A value and my B value, but I haven't written it properly yet. So we'll go ahead and put it in the position vector formats. All right, let's go into example number 5. Now, example number 5 is actually slightly tricky because it's so easy. So remember, I keep telling you, ask yourself 2 questions. What do you have? What do you want? And when you answer those 2 questions, you should be answering with one of these 2 things right here. All right, so this should be the answers to the 2 questions. So come back to example 5. This one's going to be a little tricky. What do you have? Well, you have legs. You have your A value and you have your B value. Oh, but wait a second. I also want legs. So in this one's so easy that students frequently miss it because they think there's no way this can be as easy as what it looks like. I have legs. I want legs. All it's asking me is to just change the format. Instead of using the pointy brackets, I should be using the I's and the J's. So I'll rewrite this as 6I minus 3J, keeping my A's and B's in there. All right, look at number 6. Now I'll move it down in just a moment, but I'm going to keep it right where it is for the moment. Take a look at what you have. Again, the 2 questions, what do you have? What do you want? What do you have? Well, you've got your direction angle, which you know means theta. And you have your magnitude, which you know is the length of the vector, also known as r. So you've got r's and thetas. What do you want? You want legs. Okay? So let's use our handy-dandy formula once again. There's my A formula. There's my B formula. Let's plug in our r's and thetas. And then we need the unit circle on this one. So 210, the cosine value is negative root 3 over 2, and the sine value is negative 1/2. So we'll multiply each of those by 3, and my A piece is going to be negative 3 root 3 over 2 times I. My B piece is negative 3/2 times my J. Now, I've written this slightly different here, a different way. When you go and write down what you had with your I's and your J's, let me just ask you this. Does your I look like it's on the level of the numerator or the denominator? See, what I've written over here is the exact same thing as what I wrote the first time. I just rearranged it. The deal is, though, the second time, nobody's ever going to ask me if it's on top or on bottom. It's very easy to tell where it is. Okay. Same thing with the J. Your I's and your J's should always be on the same level as your numerator and never on the same level as your denominator unless it's actually in the denominator. All right, let's look at example number 7. Again, what do you have? What do you want? So what do you have here? Well, you can see that I have my R's and thetas. My directions tell me I want my A's and B's. So I'll set up my, I'll set up my R cosine theta and my R sine theta. I'll need the calculator on this one. And so my A value and my B value are both going to be decimals. And all I need to do from here is go ahead and put it in the right format using the I's and the J's. And that's all that this question is asking. Okay. Let's look at example number 8. So again, what do you have? What do you want? In example number 8, you'll notice that I have the legs and I want R's and thetas. Remember that magnitude is R, direction angle is theta. So I want R's and thetas. And in this case, I want my thetas to be in degree mode. Okay. Now, there's something that you need to maybe write down in the margin. When you have legs, when given legs, I'm going to write this down here. When given legs, draw a picture. When given legs, draw a picture. Okay. Just something that, again, we will do this for the rest of chapter 11, and I'll keep it consistent with that. So whenever you're handed legs, go ahead and draw a picture. You can tell that I've already drawn my picture in quadrant 2 because my X value is negative, my Y value is positive. So here's my x value, and here's my y value. I'll do a little bit of math here to find my radius, my hypotenuse. Folks, Pythagorean theorem, just go use the Pythagorean theorem. Hey, wait a second. I just found my r value. So my r value is 8. That was the first thing that I was asked to find, was my r value. So I found half of what I was asked to find. Now, to find theta, let's take this a little bit more slowly here. Okay? To find your theta, I want you to look at your picture and I want you to tell me which of the two pieces are the prettiest pieces. Which two pieces are the prettiest? I think that you would agree with me that the adjacent and the hypotenuse are the two prettiest numbers on that triangle. Well, think with me to SOHCAHTOA. Who uses adjacents and hypotenuse? Well, that's going to be cosine. So the cosine of my angle is going to be the adjacent over the hypotenuse. Oh, but wait a second. That just reduces to a -1/2. And so then all I have to ask myself is, on the unit circle, where in the second quadrant is my cosine value equal to a -1/2? Let me say that again. Where in the second quadrant is my cosine value equal to -1/2? I need my unit circle for this, and I find that my value is going to be at 120 degrees. And again, I'm using degrees because the directions told me to. All right. Now, example number 9, once again, what do you have? What do you want? You have legs. You want r's and thetas. And so the first thing I'm going to do, since I have legs, I'm going to draw a picture. And so here's my picture. And you say, wow, I can't draw a triangle here. Oh, but wait, all I need is r and theta. So what's my radius? If I were to actually draw a circle with this guy right here, what would my radius be? Well, we know that my radius would be 12. Folks, you still cannot have a negative radius. Not until the very last section of this course. So for right now, there are no negative radii. And so the radius is going to be 12. And then the second question is, what's my theta? Well, you can know by using your unit circle what the theta is at this particular position right here. And we know that theta is going to be 270 degrees when I'm working in degrees. All right, so then we have the dot product. Once again, please go back and make sure that you use the notes videos for this. I'm not going to go through everything. I do have case 1 and case 2. Notice that case 1 is when you're given legs. Case 2 is when you're given r's and thetas. I did ask you to rearrange and find the cosine of theta. And so I'll go ahead and give you that. When you take this particular equation and rearrange it to isolate cosine theta, you get u dot v divided by magnitude of u times magnitude of v. All right, so you need to have this available to you as we work through example number 10. All right, so I'm not going to show both of them, so just so that you know. Now, ask yourself, first question. Since there's two cases for the dot product, am I given legs or am I given r's and thetas? And you can tell that I'm given legs. So go back to case 1 where you're given legs, and you're just going to plug into the little formula there. A times, I'm going to write down the vectors first. When I take the first vector dot the second vector, I'm going to take a times c, so that's my -3 times 7. And I'm going to add to that 8 times -5, my b times my d. Clean that up, and you'll get a -61. Okay? Now, let's use both cases to find the angle between two vectors. This 4-step process you're going to want to get familiar with so that you can do this on your own. Let's just jump right on into example number 11, but make sure that you have this 4-step process handy. We're going to do example number 11, and folks, I'm just going to tell you right now, we're going to get to the end of it, and we're going to go, oh yeah, duh, I knew the answer to that. I didn't even have to go through all that work. But I want to go through the work with you on an easy question so that on something that's more challenging like number 12, when I can't do the same thing, I can go through the math and I'm comfortable with the math. All right, so remember there's a 4-step process. So for number 1, we need to find u dot v. So you look at number 11 and you notice here that I have 2 vectors and both of them are written as legs. Okay, so I've got legs. Let's use my case 1, the leg case, to be able to find u dot v. That's like the last example we just did. All right, so u dot v then is going to be these 2 vectors multiplied together. So this is going to be my a times my c plus my b times my d. Clean that up and you're going to get 8. Okay, so that's step number 1, get u dot v. Step number 2, go find both of your magnitudes. Now you remember in the notes video, magnitude is simply found by using the Pythagorean theorem. Okay, so magnitude, that's not a difficult concept. So the first thing I do is, remember that I told you that whenever you have legs, you want to draw a picture? And so that's the first thing that I did. There's my first vector's picture. The magnitude then is just simply going to be 4. I don't even need to use the Pythagorean theorem because it's on an axis. But my second vector, not on an axis, I draw my little triangle, I do the Pythagorean theorem, and I'm going to get here that my magnitude, my radius, is 2 root 2. Okay? So I found both of my magnitudes then. All right, let's come back to step number 3. Step number 3 says use case 2 to plug in the results from the last 2 steps. Let's come back up to case 2 and let's talk about what that means. This is the version of case 2 that we're going to want to use. And so we're going to get cosine of theta. We don't know what theta is. That's what we're trying to find out. But I now have u dot v. That's going to go up on top. And I have both of my magnitudes, which are going to go down on the bottom. So let's come back to our example. So using our equation, cosine theta is going to be u dot v. Remember that was an 8. Times my 2 magnitudes. Or I'm sorry, divided by the 2 magnitudes on bottom. So let's clean that up a little bit. Okay, clean it up in your own scratch work. I didn't take the time on this video to clean it up, but you end up with 1 over square root of 2. I did some canceling here is actually what I did. And then I rationalized the denominator to get root 2 over 2. Oh, this is on the unit circle. So case 4, or not case 4, step 4 says to solve for theta. I don't even need my calculator on this one because all I'm looking for is where on the unit circle does the cosine of theta equal the square root of 2 over 2. And so I've got several different places, 2 different places. It's either going to happen at pi over 4 or 7 pi over 4. My directions didn't tell me whether I should use radians or degrees, so if it didn't tell me, then I'm allowed to use whichever one I want to. So you can either use the 45s or you can use the pi over 4s, okay? And so I'm going to use here degrees, 45 degrees. And you say, well, why did you throw out the 4th quadrant? And this is going to go back to case 2 here. Notice that your case 2, theta is always going to be between 0 and 180. So I cannot use a negative 45 degrees. I cannot use a 315 degrees because both of those are not in between 0 and 180. So I told you that we were going to get to the end of this question and we were going to say, oh yeah, duh, I should have figured that out without all of this work. Let's go back to the 2 original vectors. The 2 original vectors, one was here on the x-axis and the other one split the first quadrant exactly in half. And you say, well, what's the angle between those 2 vectors? Well, that's 45 degrees. Oh yeah, duh. But unfortunately, with example number 12, there's no way that I can make it make sense like that. So occasionally you'll run into one that's totally logical. But number 12 is not going to be logical. So let's follow the same 4-step process for number 12. And we'll find the angle between the 2 vectors for number 12. So step number 1, find u dot v. So that's going to be A times C plus B times D. Clean those up, and you're going to get 9. So that's step number 1, U dot V. Step number 2 says to find both magnitudes. Now remember, when you're given legs, you should always draw a picture. So the first thing I'm going to do is draw my picture. All I drew was the legs. Here's my radius. And so I'll use the Pythagorean theorem then to find the missing piece. So the magnitude, the radius of vector u is just 13. Go draw a picture for the second vector. First quadrant. My second vector has a radius of the square root of 13 when you do the Pythagorean theorem, which I did not show. Now let's go to step 3. Step 3 says that we should use our formula cosine theta equals, remember that on top was my u dot v, and on bottom was going to be my 2 magnitudes multiplied together. Now you're looking at this. Step 4 says go find theta. When you look at step 3, you say, how do I find theta? Well, inverses find angles, so we'll use our calculator. We'll do the cosine inverse of 9 over 13 root 13, and we'll get 78.9298 degrees. Once again, your directions didn't tell you whether or not you should be using degrees or radians. So for this particular one, I just chose to I happened to choose to use degrees. Okay. All right, and then you also had a short little video about orthogonal vectors and parallel vectors. One comment on here, when I have parallel vectors, the reason that you could have a plus or a minus, think about 2 vectors that are parallel to each other. Remember, vectors, the direction matters. Well, if both of my vectors are going in the same direction, this is where I'm going to have a positive. But if my vectors are going in opposite directions, this is where I'm going to have a negative. They're still parallel to each other. It just is an indication of the direction of them. So that's just a small comment there.